What we're going to do today is we're going to look at this series here where we're going to prove using double summations, which is what we've been working on recently, that the sum of the first n cubes is equal to the sum of the first n numbers squared. What do I mean by that? So basically, if we look at 1 cube, well, 1 cube clearly is 1. And if we look at the sum of the first 1 numbers squared, well, it's 1. Let's have a look at 1 cubed add 2 cubed. Well, 1 cubed add 2 cubed is 9. And 1 add 2 squared is 3 squared, which is 9. And if we look at 1 cubed add 2 cubed add 3 cubed, which is 9 add 27, which is 36. That's 1 add 2 add 3 squared, which is 36. And just do one more. 1 cubed add 2 cubed add 3 cubed add 4 cubed is 100. And 1 add 2 add 3 add 4 is 10 squared, which is also 100. So therefore the sum of the first n cubes, which is exactly what this is saying here, the sum of the first n cubes is equal to the sum of the first n natural numbers squared. How do we prove that? Well, normally you would prove it using induction, but what we're going to do, as we've been using double summations, we're going to prove it using double summations. So what we're going to do, we're going to start with k cubed add k squared, okay, and we're going to rewrite that slightly as 2k times k plus 1 over 2. Now that basically, if we expand that out, that gives us k cubed add k squared, so there's nothing substantial there. Now if we sum that between k equals 1 and n, then clearly that is the same as summing that between k equals 1 and n. So let's focus on this bit now. So that equals 2 times by the sum between k equals 1 and n of k times k plus 1 over 2. Now, let's have a look at k plus 1 over 2. Well, we know that k plus 1 over 2 from previous videos. We know that that is the sum from whatever, let's say j equals 1 to k of j. The sum of the first j natural numbers up to k is k plus 1 over 2. So we can rewrite this as 2, the sum between k equals 1, k, the sum between j equals 1 and k of j. Okay, so now we have our double summation. Now what we want to do is we want to flip these two, and because this is not independent, because j is going from 1 to k, we can't just flip these summations around. What we have to do is we have to rewrite it as the sum between of jk between 1 less than or equal to j, less than or equal to k, less than or equal to n. Now, I'll just explain that a little bit, because basically over here, j goes from 1 to k. So j is always less than k, and k goes from 1 to n. So that is the same as this, where k is going from 1 to n, and j is going from 1 to k. So we can rewrite it like that. And another way of rewriting that is equal to 2 times the sum of j from j equals 1 to n, because we know that j goes from 1 to n. Well, if j is going from 1 to n, then k must go from j to n. That will be the sum of k from k equals j to n. Okay, now that equals 2, the sum from n, j equals 1, j. Now the sum from k equals j to n is equal to the sum from k equals 1 to n of k, take away the sum from k equals 1 to j minus 1 of k. All we're doing there is we're saying that the sum of k from j to n is the same as the whole sum from 1 to n, take away the sum from k equals 1 to j minus 1. Okay, so, and that equals 2, the sum n j equals 1 j, times by, okay, well the sum from k equals 1 to n of k is n plus 1 over 2. And that's just the sum of the first n natural numbers. And here we have the sum of the first j minus 1 natural numbers, which is j minus 1 j over 2. Okay, and if we continue here, we can now cancel out these 2's. So that gives us the sum between j equals 1 and n of j n plus 1 n minus, and now we're going to just expand that, minus j cubed, which is j times minus j times j, add j squared. Okay, which equals the sum between n and j equals 1 of n plus 1 j minus the sum from j equals 1 to n of j cubed, which is that one, add the sum from j equals 1 to n of j squared. All I've done is I've said that the sum of all of this thing here is equal to the sum of that bit minus the sum of that bit, add the sum of that bit. Okay, now here's a bit I'm sure that people aren't going to be very happy with, but if we just look at this here, that is the sum from j equals 1 to n of j cubed. That is the sum of the first n cubic numbers, and this is the sum of the first n square numbers. Well, we can replace j. J is just a dummy variable. We could replace j with k or l or p or smiley face or whatever we want to. So we can replace it with k. So that was the same thing. It's just a dummy variable, k cubed, add the sum between n, k equals 1 of k squared. Now, if we go all the way back to where we started, what is it that it actually equals? Well, it equals this. It equals the sum from k equals 1 to n of k cubed add k squared. So this thing here actually equals the sum from k equals 1 to n of k cubed add the sum from k equals 1 to n of k squared. Well, the sum from k equals 1 to n squared cancels, and we can add here, that's the sum from k equals 1 to n of k cubed, and that's the sum of k equals 1 to n cubed, so we can take that over the other side, and that leaves us 2 sum of k equals 1 to n of k cubed equals the sum from j equals 1 to n of n plus 1 j. Now, looking at this here, n plus 1 is a constant, and the sum of the first n natural numbers, which is what the sum from j equals 1 to n of j is n plus 1. So the sum of that is n plus 1 over 2. And we're almost there now. Basically, all we got to do now is we have that 2, the sum from k equals 1 to n of k cubed equals this. So taking the 2 over, we have that the sum from k equals 1 to n of k cubed equals n plus 1 times n plus 1 over 2, which equals n plus 1 over 2 squared, which equals the sum from k equals 1 to n of k squared, which is precisely what we were trying to prove in the first place. And so therefore we have proved all the way up here that the sum from k equals 1 to n of k cubed equals the sum from k equals 1 to n of k squared, using double summations. Well, I hope you found that useful. If you did, please like this video and subscribe to the Gresti Academy YouTube channel. Thank you very much.